Sorry about that. All right. Good. So let's see, 27. Well, I mean, doesn't even matter. I can just make some up. So 27 looks something like this here. Yeah. So what value of y could I not use? Can't use 2. I like it. So the bottom can't be 0. So the y can't be 2.
Oh no, it was the one that made it like kind of confusing was the denominator was 3y minus 7. So did you put a fraction there for y? Instead of you put
Totally. I mean, the beautiful. I really want you guys to realize this first step. I don't have to worry at all what's going on with the bottom yet, right? Oh, sorry. Did I take your normal seat? Oh, let's see if it'll still. Yeah, cool. Okay. Yeah. It's only after I write the bottom can't be 0, then I worry about how to solve it, right? I mean, so if you have a problem like, notice I'm trying not to do all your work for you. If you have a problem like this, what can't happen? The bottom can't be 0, and then solve it. So you don't have to kind of reach for the answer or figure out what the answer is in your head. Just solve that equation. Just solve it. How do you solve that equation? Add 5. And then divide by 4. So z can't be 5/4.
So you set it basically to 0.
Yeah, exactly. Yeah. I like it. Yes.
That one online, but I can't remember the number. But it's going to be
The problem. Okay, you can do that. What you got?
25 over 6 divided by 5 over 7 divided by 1 over 5.
Well, 25 over 6.
Divided by 5 over 7 divided by 1 over 5. Or written the other way. Going across.
Okay. Divide by, sorry, do it again.
5 over 7.
5 over 7.
And divided by 1 over 5.
Okay. So what do you think the first thing is I should do here? Yeah, I know what division of fractions means, so let me write this a little bit better way. Right? When I divide by a fraction, I multiply by its reciprocal, and I multiply by its reciprocal. And then you just go to town. You know, there's only one thing you can really kill here, right? I mean, you could do this and this, or you could just go 5 dice. Now, can you reduce this at the same time? No, there's only 1 5. It's already dead, right? And then you just multiply across. Is that cool? Yeah. Okay. Before I forget, one thing on the quiz, it's kind of related to this, sure, Jeff, say it. Drives me a little crazy. Is division. All right, some of you guys know what I'm about to say because I've written it on so many papers. Tell me, where is division in this statement? Is it at the end? But at the same time, I don't want to be too evil because I understand why you think this. Because in this problem, somebody actually wrote it like this, which gave me a chance to say this is a different problem. But in this problem here, obviously, what do I do last? I divide last. I got to know what the top is. But if I want to write this in one line, how could I rewrite this correctly in one line? If I do this, if I rewrite it like this, I am wrong. That is not the same problem. Those are not the same problem. Those are completely different problems. Yes, ma'am?
Why?
Because this one is saying divide this by this, when I should be saying divide that by that.
Oh.
So what's not needed here, but is needed there, are the parentheses. How do I know what the top is? I look at the top. But when I write it in one line, how do I know what the top is? Oh shit, there's no top anymore. I'm going to tell it what the top is. So if there aren't parentheses here, you don't do division last. So why is division last here? Because everything else became the first thing to do, didn't it? This is the first thing to do, and that's the first thing to do. So what's the last thing? The poor little divided sign. But if I had this problem, division is not last. Hell no. It's there. It's in the middle. It's not last. What are the last things here? 4 minus and the plus 2 cubed, right? That's the last things I would do because they're at the end of PEMDAS. So I don't blame you on one level because you do enough of these problems, you start to generalize it. Division's always last. No, we know it's not always last. It's in the middle of the statement. So what makes it last here is there's understood parentheses that separate top and bottom, and then that becomes first. And poor little division dude's like, well, I guess I'm last. Shit. Yeah.
Technically, wouldn't that be plus 8 would be last because you would have
Yes, plus 2 cubed, which is 8. Cool. I
because
like
you
it.
have to do the exponent before everything else.
Exactly. Yeah, but if I say 2 cubed, it's the same thing as saying 8. Yeah, cool.
But
I
the
like it.
order of operations would be different.
Yeah, so you add whatever 2 cubed is, and it's 8. I like it. But you add and subtract last. I like it.
But you make it 8
Yes.
first after the
Which you definitely add and subtract last. I like it. Cool. So that was one thing I almost forgot. But this happened enough. But again, it's just because we do so many of these problems, we start to generalize the wrong idea. I like it. Cool. Yes?
18 over negative 18 is still negative 1.
Totally. I like it. Because there's no negative in there to kill that negative, so he's still alive at the end. I like it. Yeah.
Can you go over number 45 on 7.2?
Oh, let me. All right. I'm going to do half of this problem the traditional way. And I'm going to show you a cool little thing that if you don't understand it, you never have to do it. It's just a little shortcut to these kind of problems. So we're talking about this, let's see, where'd it go? The 2x squared minus x minus 3, that one? This is 7.2.
3x squared minus 8x minus 3. 3x plus 1 all over 2x minus 3.
Okay. So what I mean is, now, what are the only, how many factorings do I have to do up here? A couple, right? This guy and this guy, those are just one piece. All right, so I don't have to worry about those. So let me do this one the traditional way. How do I factor this correctly?
2 times 3.
Yeah, okay, cool. And some of you guys might realize, there's only one way to factor 2, and there's only one way to factor 3, so that, like, the trial and error method wouldn't take as long here, because there's not as many things to try. But just to do this by the book, factor -6 to make -1 with a sort of staring me in the face. 2 and -3, yeah. Let me stop there for a second. Is everybody decent with what's happening? Cool, I like it. And the whole idea here is, I want to take that 3-term dude and turn it into a 4-term dude, which should be easy. We had some trouble with that. That very last problem for everybody on the quiz was a 4-term dude. You just have to group that bad boy, right? 4 more terms, you group. So that's why I'm trying to make this into a 4-term dude. So I can rewrite the middle, 2x squared. I would put this first, minus 3x plus 2x. So what comes out of here? X. What comes out of here? Something always comes out. Something always comes out.
Negative 1.
1.
1.
I like it. If nothing comes out, 1 comes out. And why would you do that? Just to make it look more like what you're used to. Now there's no question about what's going on. It looks exactly like I'm used to, right? So if you can't take anything out, you can always sort of take out a 1. Because it won't change it. So then what's the answer for this top piece here?
X plus 1. 2x minus 3.
Alright, cool. So that's the traditional way, and that would go back there. Notice how that is a part of, and that's going to cancel, isn't it, on the next step? You guys see that this is here, it's going to cancel when I put it back in. Okay, so you can do that same exact thing we just did. You can do it obviously on this bottom piece, right? Obviously. I'm not going to. Nah. I have a clue. What most likely will be a factor of this? Probably this. Let me see. If you don't understand what I'm about to do, it's not horrible. Because you can just do this, and that's beautiful. You got to be able to do this anyway. But this is a beautiful shortcut for when I have a hint in the problem. Just like that was a part of this, I'll bet you anything that's a part of this. So now, watch this. Let's see if you guys get this. So the second little piece here that I worry about, I'll do over here, but I'm going to do it a slightly different way. I'm going to say, I'm pretty sure this has got to be a part of the answer. So then, what makes 3x squared? What has to go here? X. That'll be 3x squared. And what makes negative 3? That's got to be minus 3, right? And the only thing I got to check, because this might not be right, but it's a good guess. It's a great place to guess, because then I don't have to, don't have to do this crap if it works. What do I have to check? I just got to make sure I get the middle term. So what do I get? I get minus 9x plus x is minus 8x. It worked. So if you do all this for this, you'll end up here. The shortcut was just because that acts like a hint. I'll bet you anything that is a part of the answer. Now, if you don't understand the shortcut I just did at all, you got to understand this, period. So you just do this. Right? So let's real quick just do this way, just to verify that's true. So if I want to factor this, I would first do that. So that's the answer. We're just going to do it a different way to make sure it's right. Factors of negative 9 that make negative 8.
1 and negative 9.
1 and negative 9. You got what? So then I can do 3x squared minus 9x plus x. I like it.
Minus 3.
And see, the same kind of thing's going to happen here that happened here. Right? Let me stop there for a second. So what comes out of these first two? 3x.
So it's x minus.
And of course, out of here, I can take 1. And so I get x minus 3, 3x plus 1. That's what we got. Cool. Almost always there'll be about 50 different ways to do any problem. Right? You just choose the way that makes the most sense. So when you plug this back in, you plug this back in, that ends up canceling, and that ends up canceling. Is that cool? You should be able to finish that out. Give me nothing. I like it.
So we just
Don't give him anything.
X plus 1 over X minus 3.
Yeah, it'll be x plus 1 over x minus 3. Yeah, the parts that survive.
I got a question on finishing. So for the test next week, chapter 7 and 8 homework needs to be completed and turned in?
By Wednesday. I love it. Yeah. Like, what? Are you crazy? Yeah, it's summer, man. Yeah.
So when you have the 2x squared minus 3x plus 2x minus 3, when you factored out that plus 1, where did that come from? That you have it that you factored out?
Well, it's like, where'd this one come from? Okay. Because how do you factor negative 9? One way to do it is 1 times negative 9. Right? So what can come out of this? Nothing except 1. And why do I do that? Because if you don't, it looks like this. If I didn't do this 1, people just write this, and then it gets a little confusing. That looks weird. Doesn't look like we're used to. I guess, so you don't have to do this. It just makes it look more like what I'm used to. So people get confused about where to go from here. Does that make sense? I mean, that's why this is weird, but it's true. And it forces it to look more like what I'm used to. So then I know how to write the next step. I like it.
Section 7.1, number 8.
Oh, alright. Okay. Let's take this shortcut for a test run. It's like I planted you or something. Is everybody cool with what's up there? Where to go away? It's going away. Okay.
Number 83. Section 7.
7183. Now, this does not have to be true, but it only kind of makes sense. Our book is going to give us problems where something actually happens most of the time. Right? So, what has to be a factor of the bottom in order for something to happen?
Make the same as a-
Yeah, the x minus 3 has to be a factor of the bottom, right? Now again, if you don't like this shortcut, you would just do 3 times 6 is 18, and get factors, make negative 11, and break up the middle term, and blah, blah, blah. But if the problem gives me a hint, I want to know how to use that hint, right? You can't always do this. True, you can't always do this, but in this situation, that has to be a part of this in order for the next step to happen, right? So if I assume it is, what has to go here to make 3x squared? 3x, right? So the x would make x squared, and the 3, now that's 3x squared. What has to go here to make positive 6?
-2.
Negative 2. And then I got to check, because maybe this is wrong. It's a complete chance this is wrong. So what I get when I check it, I get negative 2x minus 9x is negative 11x. So it is right. If that check doesn't work, I'm like, oh crap, I guess this doesn't, I can't reduce this. Okay, no big deal. I don't know if you guys are with me or not. And again, 3 times 6 is 18. Factor of 18 to make negative 11, or negative 2 and negative 9. You break up the middle term and do all the stuff we just did a minute ago. Group it, so forth. You'll eventually get here. And then what's the answer? What happens?
1 over.
Good. That cancels to 1, so it'll be 1 over 3x minus 2. Take gas. Be careful about where your survivors are.
Can we do more examples?
Second?
Like more exercises? Just to see how we do it here. It's
That's
not necessarily we do it, it's just first.
very true. Because you're in the next level now.
Oh.
But again, it's just when you happen to notice when the only way this is going to work, just like the last problem, the only way this is going to work is if that is a piece of this. Right? So then I assume that that is a piece of this, and I see if it works, if I assume that.
I don't know if it's because I haven't done it in a while, but like number on 7.2, on the basic like division and like simple fractions, you just flip it and multiply, right?
Yeah, and I'm glad, look at that. You guys are awesome. That was something else I want to talk about. Why do you do that?
We made up
Yeah, why? Like if I have 4 15ths divided by 2 fifths, I mean, what's the official way to do that?
415 times.
You multiply by the reciprocal. This is a beautiful place for me to say to you, again, you never just go, well, the math teacher said so that's the way math doesn't make any damn sense, so whatever you tell me to do. Sorry. I don't know if that's any of your feelings about it, but I've heard that kind of thing before. It's got to make sense. Why the hell would we do that shit? There's got to be a reason. It can't be just, how we do this, let's just do this. Oh, it looks good. So I'm going to do something really strange to explain why the process we use works. You guys with me? Because how would I do this? I would just make it 4 15ths times 5 halves, reduce, and then be done with it, right? That's how you do it. Now, why does that work? It's going to take a little weirdness. So go with me for a second. I'm going to write this the way I would never write this. 4 15ths divided by 2 fifths. Now somebody help me out. Why is that particularly disgusting?
Complex fractions.
Yeah, there's fractions inside of fractions. Officially, it's called a complex fraction. We have a whole section coming up in our future about complex fractions. Oh shit, Jeff, thanks for doing this. That looks good. So now stay with me. The real reason it's disgusting is because the bottom is not 1. If the bottom was 1, would it be a fraction? No, 7 over 1 is 7. That's not really a fraction, right? So how do I can multiply top and bottom by anything except 0. Right? You can't multiply top and bottom by 0. You can multiply any other thing you want to in the universe. You guys semi with me here. So I can multiply top and bottom by square root of pi. Why would I do that? So I'm not going to.
Multiply the bottom by the 1/5.
So what's going to make this become 1?
5 over 2.
5 over 2. So this equals this, which equals 4 15ths times 5 halves. Because what happens on the bottom? It becomes 1. So I don't need it anymore. That is the reason why when I divide by a fraction, I multiply by its reciprocal, because this is what would really happen in the background. So this actually is sort of a shortcut that I don't know if you've ever shown why it works. But see, that's the little pieces that are missing from math that students go, they said to do it this way, shit, why not? And then you lose complete faith in math. And I don't like that, obviously, because I sort of have a lot of faith in math. Okay. You like a faith. So then you get the same answer, right? I like it. Is that cool, you guys? Some of you guys, like, I could have lived without ever seeing that, Jeff, but too bad. Cannot be unseen. Okay. Anything else from homework? Did I actually answer a question, or did it go off on a tangent? Yes?
Homework for online?
Oh, sure. Yeah, if you're doing online homework, you can certainly bring in problems. Well, that's nifty. Which section is that from? Is it 7.5? If it's 7.5, we haven't done it yet. I'm pretty sure this looks like 7.5 to me. So we're going to get into that today. So hold on to this. Yeah. Yeah, we still got to finish out 7.4. All right. How are we doing? Anything else from homework? All right. So let's get into some new stuff, or finish out something we barely got into last time. So I put that last problem on that group work that involved not like denominators. And the process I showed you works for everything, period. So just to remind you what I'm talking about, if I had to do 11/60ths plus, what do you got, Jeff? 1 over, I don't know, 45, sure. I like it. So first start with numbers, and then we're going to use the same idea with variables. I really don't feel like listing out all the factors and seeing which ones 45 agree with, because that 60, 120, 180, 240, please, dear God. No, screw that shit. I want something more direct I can do. So can somebody tell me what's the biggest number these have in common? 15. I love it. Cool. Right, and that's sort of the first step to get over is, can you see what that is? So 60 is 15 times 4. And 45 is 15 times 3. Now the problem becomes crazy simple. What's this guy missing that he has? Another 3. They both have 15. He's missing a 3. He's missing a 4. So if you give this guy, oh, you've only got 2 colors. If you give this guy a 3, and you give this guy a 4, now they both have the same denominator. Is that cool? And what is that denominator? 60 times 3? 180. So then I get 33 over 180 plus 4 over 180 equals 37 over 180. No big deal. All right, so you're kind of chopping the numbers down. They're so big, I chop them down by using the largest common factor that's already there, so I can only focus on the parts that aren't the same. So we do the exact same thing with variables, and to be honest, it's actually easier with variables. Right? That's not a phrase that you normally immediately believe when I say it. But this was kind of weird to get this 15, and some numbers are really difficult to see what's the biggest thing that goes into both. But variables, they can't hide anything. There's only one way to factor expressions, right? So, for example, if I have you can do it, Jeff. There you go, buddy. So what is the first step here? Factor. I love it. So this is what I mean by it's easier. How many ways are there to factor 45? Quite a few. Think about it. 5 times 9, 3 times 15, 45 times 9. How many ways to factor 60? Even more. But how many ways is there to factor x squared minus 9? 1. I like it. So how many ways is there to factor that? Just one way. What is it?
7 or 8.
You're thinking multiply for 15. X plus 3. X plus 5. I like it. Let me stop there for a second. Please let this be simple. And again, if you're able to factor, this is easy. I don't even want to say, well, no, it's easy. It's just easy. If you know how to factor, it's easy. What's this guy missing that he's got?
X plus 5.
X plus 5. So guess what you do? You give it to him, right? So you give him x plus 5. And what's this guy missing that he's got?
X minus 3.
So you give him x minus 3. I like it. Now please, dear God, let me see. Never multiply this back out. It's just extra crap. Don't. Because what's the last thing you have to do with a fraction? See if it reduces, right? And if you multiply this back out, you're going to have to refactor the damn thing anyway to see if any parts. So just leave it, bam, bam, bam. So the bottom is going to be bam, bam, bam. And what do I get on the top now? What's this? 4x plus 20 plus 3x minus, sorry, that's a 3. It's 9. Don't apologize for my poor writing. It's all on me. So you end up with 7x plus 11, 7, 11. Oh, x plus 5, x plus 3, x minus 3. Can you reduce that at all? No, because you can't factor that, so it's not going to have any of these in it. So you're done. You would be done. So it is based on what we do with numbers. It has to be because variables are numbers. So they have to act the same way. But to be honest, if you know how to factor, it's actually easier. Because there's only one way to factor these. There's millions of ways to factor those sometimes. Holy shit. But maybe. Maybe I have some people believe me. Alright. It's normally the way it works best is when you believe the teacher. We'll see. So you guys try this one. Let me see. My poor printer ran out of ink, so I couldn't print this out for you. I'll give you one that's not too evil yet. Sure. Just to help you a little bit, what's the only thing you can do to the top and bottom of a fraction? Multiply or divide. That's it. You can't add stuff. You can't say, well, it's missing a plus 2. Let me add 2. You can't do that. You can multiply the top and bottom, or you can divide the top and bottom. So multiplication is what's going to help us here.
So there's nothing you can cancel.
Nothing you can cancel out of it. You kind of always look to see if anything will reduce. Nothing does. How do you factor this, dude?
X
I like it. So then you can see what that dude's missing.
X minus 1.
Kick ass. They struck oil. It's a gusher. And now you've got the bottoms are the same, so you're allowed to go ahead and put them together. So I told you the other day why I distribute. Because if you write it like this, people are going to cancel that x minus 1, and that's completely illegal. So I don't even give myself that option. I say, okay, there's 3x, and then this is... I like it. All right, go ahead and distribute before you write it down, so you're not tempted. Because if you write it down like this, part of your brain will say, oh, sweet. Totally illegal. You can't break into an addition problem and do that. But I don't blame your brain that much. It's like, there's so much shit, let's get rid of some of it. But it's illegal. Can't do that. And then, of course, the last step.
7x.
Yeah, 7x minus 4. And that won't reduce. I like it. I like it. How do you guys feel about that? Is that... I mean, the thing with my Math 90 students, I'm going to say this some more again this semester. So what I said all the time was, math doesn't care about what's in there, it just cares about the process. Once you understand how a process works, you can attack anything that looks like that using that process. So there's not a million different things to learn in math. There's like 10. And then those 10 things apply to all these problems. There's not really just 10, but you get it. For us this semester, maybe about 10. All right, here, let me show you a problem where people make a big mistake. So the mistake people make, don't even write this down, is let's say, oh, this guy's missing a -1. Okay, there we go. Now they're the same. Yay. But they subtracted 1 from top and bottom. If I could subtract 1 from the top and bottom, then 1/2 equals 0. You won $500,000. Here's your no money. Damn you. So thank God math doesn't work that way. Do you guys understand what I'm saying? I can see why people would say that, but that's crazy. What's on the bottom here? An X. And what's on the bottom there? X minus 1. Does this guy have an X anywhere? No. This guy has no X anywhere. He's got a 2 on the top, and he's got an X minus 1 on the bottom. So obviously, what's this guy missing? He's missing X minus 1. What's he missing? X. Now they both have the same. And then you just do like all you do. What do you get here?
5x minus 5. 2x.
Become a minus.
3x minus 5.
And we know we're done because you can't factor that, so nothing can cancel.